Welcome for another physics lesson. We're going to look at photoelectric emission, and we'll be focusing on a question here which says that the minimum frequency of light which will cause photoelectric emission from a metal surface is 5.0 times 10 to the power of 14 Hz. If the surface is illuminated by light of frequency 6.5 times 10 power 14 Hz, calculate part 1 the work function of the metal, part 2 maximum kinetic energy of the electrons emitted, and part 3 the maximum speed of the electrons emitted, of course. Remember to subscribe to this channel as you continue reading. Refer as many friends as possible so that they may also benefit. Let's look at the solution to this question. So now, because we are taught to find first of all the work function, we should know that work function is the minimum energy which is required so that electrons are dislodged from a metal surface, and it is given by Planck's constant times the threshold frequency. Threshold frequency on the other side is the minimum frequency for photoemission to occur, or the minimum frequency below which photoemission will not occur. Therefore, and for this metal it is already provided, so work function is going to be gotten by Planck's constant, which is 6.63 times 10 to the power of negative 34. Then this we multiply by the threshold frequency, which is a 5.0 times 10 to the power of 14. So we can now get the work function for this metal, 6.63 times 10, or 6.63 times 10 raised to negative 34. Then we divide this by 5 times 10 raised to 14, and this is going to give us just a minute, when we have 6.63 times 10 to the power of negative 34, then we multiply by 5 times 10 raised to the power of positive 14. So this gives us 3.315 times 10 to the power of negative 19. And these are joules because it is energy. Number 2, we are taught to find the maximum kinetic energy of the electrons emitted. It is very important to know that the total energy of this radiation is given by HF, Planck's constant times the frequency of this radiation. Then again, we should know that now this total energy is splitted into the work function, then the kinetic energy at which the electrons will move it. So the total energy provides first of all work function, the energy required for photoemission to occur. Then now the other part of the energy becomes kinetic, the energy at which the electrons will move it. Therefore, it means kinetic energy can be calculated by subtracting work function on this side, such that HF minus work function will give us the kinetic energy at which the electrons will move it. Therefore, we shall have 6.63 times 10 power negative 34 multiplied by 6.5 times 10 power 14. Then we subtract work function, which is already calculated as 3.1. Okay, we have another 3.315 times 10 power negative 19. Therefore, when we take 6.63 times 10 power negative 34 multiplied by 6.5 times 10 raised to 14, then we subtract what we add, 6.63 times 10 raised to negative 34 and multiplied by 6.5 times 10 power 14, we are getting 4.3095 times 10 power negative 19. So we subtract 3.315 times 10 power negative 19 too. When these two are subtracted, we are going to obtain 3.315 negative 19. So this gives us 9.945 times 10 power negative 20. This is going to be joules of energy. Then after getting these joules of energy, we can look at the part 3 of the question, which is telling us to calculate the maximum speed of the electrons. Remember, we have the mass of an electron. Therefore, we can say that kinetic energy is usually calculated by half mass of an electron times velocity maximum squared. Therefore, we can say this value, which is already determined, 9.945 times 10 power negative 20 is equal to half multiplied by mass of an electron, 9.11 times 10 power negative 31, then the velocity unknown squared. So to remain with a known velocity squared, then we can have this one times 2 divided by this mass, so that we do away with this constant here to remain with v alone. So we multiply by 2, then we divide by 9.11 times 10 power negative 31, and this gives us 2.183 times 10 power 11, such that to get now velocity, we need to take the square root of this value, such that the velocity becomes 4.673 times 10 raised to 5. This because its velocity will be meters per second. So that is how we get the velocity of the emitted electrons. Thank you for following. Make sure you subscribe to this channel and you share the link with your friends. Thank you.